Okay, we're in section 10 of the notes. This is going to be the material on partial fractions. So the big thing here is that there's going to be two integrals that you need to know about that we've discussed in Calc 1. So these needs to be known for this section over here. The other thing is that you would need to know the material that you learned in Math 119 about how to do partial fractions. We'll certainly go through examples. I'll go to the whiteboard. Lecture is going to be short though. Then we're going to reinforce, like we always do, what's being said in lecture with examples. All right, but first lecture. So let me go to the whiteboard, and it's going to be a short lecture. Oh, but it's short, relatively speaking, short. Let's take a look here, and I'm going to share. I'm going to at least share my whiteboard with you. Okay, so let me just go through what we're saying over here. All right. Now, not that I'm reading things verbatim to you, but for the most part, we would love for you to read through this material. So this section of the notes, although it's mostly a review of what you've learned in Math 120 and 121, it may appear to be new to you. All right. Now that depends on your prior background, who your teachers were, but you really should at this point know the method of partial fractions. All right. So it says, what we do is we're going to be taking these fractions now, and we're going to go through a procedure to rewrite these fractions. All right. That's what we're going to do. Rewrite the fractions with the hope in the end that we're seeing integrations that we can do. And probably the two most important ones are number 1 and number 2. So we're going to see these guys over here. Now I want to point out what this one is. The first one is 1 over an irreducible quadratic factor. All right, we know it's antiderivative. This one over here, 1 over x, that's a linear factor, would just simply be the log of the absolute value of x. So these two are important. All right. Then the question becomes well, what if we don't see those immediately? Well, we probably will see them eventually when we start to manipulate these fractions. So what do you mean by a fraction? We're going to be given a rational function. That's going to be a ratio of two polynomials, p of x over q of x, and we're going to follow these steps below, right? The first thing we're going to do, number 1, if the degree of the numerator is greater than or equal to the denominator. So over here is an example. I'll go to the whiteboard in a second, where the degree at the top is 3, the degree at the bottom is 2. So certainly the numerator, right, the degree of the numerator is greater than or equal to the denominator. What do they want you to do? Well, they want you to long divide them. All right. Now, where'd you learn long division? Certainly in grade school. Polynomial long division at Essex College is introduced very early on. But let's go through it. All right. So this is going to be a really important first step. So 3x squared minus 2x minus 1. I'm going to divide that into 6x cubed plus 5x squared. Now, a lot of students have to put the missing place in. If you do, put it in. It would be no x's, right? And then minus 7. If you don't need to do that, don't do that. All right, let's take a look at that. What am I going to do? What multiplies 3x squared to match the 6x cubed? Well, that would be 2x. Let's write that down. So what do you get? 6x cubed minus 4x squared. Then what do? You have to subtract. What do you get? 9x squared. Let me drop a place down, or the places I should say, and repeat until you get to the edge. What do you get over here? Plus 3. What does that give you? 9x squared minus 6x minus 3. And if you did that, what do you get? You would get 6x minus, I think I made a mistake somewhere. Did I copy it right first of all? 6x cubed, 5x squared, 0x minus 7, 3x squared minus 2x minus 1. Oh, you know what? I didn't do something there. And let me write that down for you. And I apologize. I just saw it too. And this happens. Let me erase here. Let's take a look at that. And let me erase this 3 over here too. All right, made a mistake. So 2x times 3x squared is 6x cubed. 2x times minus 2x minus 4x. I forgot to multiply the 2x times the minus 1, which is minus 2x. All right, what do we do now? Subtract. What do you get? You get 9x squared plus 2x minus 7. We drop a place down. Repeat, what do you get? Plus 3. What does this give you? 9x squared minus 6x, and that's going to be minus 3 now. What do you get there? Well, if you did the subtraction, you'd get 8x minus 4. So the answer over here for this problem over here, I'll write down for you, 6x cubed. When I say the answer to the first step, 5x squared minus 7 over 3x squared minus 2x minus 1 would be equal to, let's write down, 2x plus 3, whoops, plus unfinished business. What's the unfinished business? X minus 4 over 3x squared minus 2x minus 1. All right. So I want to point out that's written over here. So this is first step, number one step. Now, by the way, someone says, is that step always going to be there? Maybe, maybe not. When do we do that step? If the numerator, the degree of the numerator is greater than or equal to the denominator, then we long divide. If that's not the case, we're not going to do it. So for example, on the second fraction, let me point this out to you. This is the second fraction over here. The second fraction, the degree of that one is 1. The degree at the bottom is 2. So I certainly wouldn't do long division there. However, I'll be honest with you, you could. And later in the course, we're actually going to do division with a problem like that. All right. But right now, what are we looking at? We're looking at step number 2. So step number 2 says, if the degree of the numerator is less than the degree of the denominator, well, I certainly see a case over there. 8x minus 4 degree is 1. That's surely less than the degree of the denominator, which is degree 2. What does it say to do? Factor it. Factor what? Factor the bottom. So, someone's going to say, is that possible? Of course it is. We don't give you problems that are not going to be working out nicely. We're going to give you problems that work out nicely. So what do you get? 2x plus 3 plus, 8x minus 4. You can factor top if you want, but the bottom, does it factor 3x, x, that's 3x squared, right? 1 and 1. I'm going to say minus plus. I would never say that's right until I check it. That's 3x squared minus 3x plus x minus 2x. It works pretty good. So that will be your next step. All right. That's the next step. Now, this is where a lot of students say, oh, my teacher in Math 120 did something different now. And they may have. I'm not saying they didn't. The method that you learned is not a bad method. I'm not saying that's a bad method. What I'm saying is that I may do something a little bit differently than your other instructors do. So I'm going to go to the next page. Before I do that, though, I want to point out, they say some of these quadratics are not going to be factorable, at least not nicely. So what they say, let me read that to you. So at the bottom page, a quadratic polynomial is called irreducible if it cannot be factored into linear factors without using complex numbers. For example, this one here, it can be factored, by the way. You learned that in Math 119 into that, but they're complex numbers. We're not going to get anywhere near that. We're not going to write that down as a factorization problem. We're only going to use it if we have, real coefficients. All right. We go to the next page, and this is where a lot of students get really screwed up. These things over here. So again, we'll go through examples, and I'll just hopefully jog your memory, which did in Math 119, and we'll go through these examples over here. Now, granted, when this is written out in an abstract way, this might be hard to follow, but we'll go through those examples. All right. So it says, assign each linear factor the sum of n partial fractions. This might be tough for you to look at and read. All right. We'll go through examples, of course, when we get there. So for example, this one over here, I'll write this one down for you. We just did it, right? We got this one over here. What does it say? Assign each of those factors, 3x plus 1, x minus 1, some constants over here. You just don't know what the constants are. Again, I'm going to go through this briefly. My problem over here is find out what those constants are now. And typically what I use, since in this classroom, we don't have many variables, I would just use the letters A and B. So I'm going to write this. I'll write this down for you. So A over 3x plus 1 plus B over x minus 1 would be identical to, what's supposed to be identical to? 8x minus 4 over 3x plus 1, x minus 1. Now, this is where your Math 120 teachers, I'm sorry, it's Math 119. Yes, 119, I'm sorry, may have done something different. They may have quitted coefficients. I don't do that unless I have to, but I will go through that method when we get to problems. Okay, now when we get the irreducible quadratics, these things over here, let me go to that. When we get to irreducible quadratics, This looks strange to a lot of students. We assigned it a factor on top that's linear. All right. So let me repeat this. These linear factors like 3x plus 1 get assigned a constant. The quadratic factors in bottom would be assigned a linear like bx, mx plus b or something. We'll use letters for that. Now, of course, when I go through these problems over here, we're going to go through the examples now. All right. But lecture's done. So what do we talk about? Let me go back to this. We talked about these really important guys over here. I bet our integrations are going to look something like that. And then we talked about the method of partial fractions that you've learned in Math 119, all right? You did that in Math 119, all right? So what we're going to do is we're going to go to problems now, and lecture's done. We're going to try to reinforce what's been said in lecture now. Thank you.